All right, good morning, everybody. This is the March 9th CAPN office hours. As always, this is recorded and posted to YouTube, so don't say anything you wouldn't want to be broadcast to the whole world. We have a couple items on the agenda, so I think we can just get started. Actually, before we do we have any new folks that haven't been here before? I'd like to do a quick introduction. And if you would, just unmute and you can start talking. Cool. All right. As well, if anybody is, if you can go and add yourself to the attendees list, I'm going to drop the actual Google Doc for this in the Zoom chat. All right, so we can get started. Chow, do you want to talk through the two items that you added to that agenda?
Yeah. Okay. So I would like to discuss two issues. The first one is when I implement the nested etcd controller, we wanted to use some existing templates. Like when we create the etcd pods, we need to know like what should we pass into the command line, something like that. So I would like to know how can we refer to templates. Like, should we put just the pod templates of the etcd in our CAPN repository, or how if there should we use any mechanism that allow user to specify what templates they wanted to use? So I think we used to we talked this before, and we decided to use the common spec from the Kubi Builder declarative pattern, the repository. But I discussed with Chris last week or 2 weeks ago, I forgot. But Chris, you mentioned that this feature is not stable right now, right? They are going to change how they are going to use this common spec, like the version and the channel, to refer to the template, right? So
no, it is. So from their side of things, it is standardized.
okay.
It's more just it. So I think what that might have been my mistake on how I communicated that. So what I was thinking was that we could go forward with what you did for the etcd implementation, and then and we could merge that, and then we can try to realign a little bit more with the declarative patterns as we go forward. So basically don't implement anything specific to that, just have the manifest in there like you currently have in the etcd implementation. And then what we can do is we can go and use their file-based or directory-based structure to actually load those manifests in, and then we just populate them from our reconciler. Was what I was thinking.
I see. Okay, so could you remind me how they achieve this? Like, I noticed that there are two fields. One is the version, one is the channel. Version means what's the version of this specific component, like 1.2.3. The channel means if this release is stable or nightly or something like that. And you just mentioned they use things like a directory to organize all this version and a channel. So does that mean we need to create directory inside our CAPN repository, or we need to host it someplace else?
Yeah, so let me actually share my screen, I guess, and I'll take you on a tour as I have used it and know about it. I'll just go through the examples that they already have. Let's see, share my screen. QBuilder declarative patterns. Cool. All right, can you all see my screen? Do I need to make it bigger or anything like that? Cool. All right. So basically, we're looking at the declarative patterns project for the guestbook operator. I'm just going to go through this because it's already pre-built. So what they actually do in here that's a little bit different is when you actually set up your controllers are written much more lightweight than what we have. In terms of the only thing it has to do is it kicks off like a common reconciler, and the common reconciler goes through and it can do object transformations on any of the resources, and you can pass it in any functions that can go and change any or mutate any of the actual manifest, the raw YAML manifest files for you. You can set owners on it, you can set labels, so on and so forth. You can preserve the namespaces. Anyways, you can read through all of those, and there's a bunch of other functions that you can pass into this init for each component. Then if we go back, how they actually structure that and how you actually point to it is in the types, you have like what you already know about, the common spec and patch spec. So the patch spec allows you to override anything you want, kind of like a customized patch. And then the common spec defines the version and channel. Now in version and channel, how those actually are set up is there's this channels directory at the base of every project. And in essence, these are just loaded into the Docker file. I don't know if long-term these will be added in with any of like the new 116 like bin data kind of styles, but for now they're basically just added into the Docker file. And you'll notice that there's a file called stable, and stable represents the channel stable. And this has a pointer to a version. And so this is how it gets the manifest for each one. So in ours, we'd actually have manifest name etcd version, whatever the version is that we have defined in our stable deployment. And then if we go back to channels, you go into guestbook. So this is, notice how the naming of the file tree happens. And then under here, you have manifest.yaml. And so that's what actually points to it. But what's nice about the common spec is you should be able to override those entirely if you want to, as long as your RBAC still suffices for whatever the changes are going to be.
So I have a question. So the version here, does that align with the version of the components or just the version of our controller? Like if we have a new version of etcd 3.5.0, then do we need to create a new version under maybe stable channel for that?
That's a good question. I would say we should follow the versioning scheme of the components. So if etcd is 3.5.4, we make a new version, and we make 3.5.5, we make another version that's in there so that you can always have those maintained. I do, Vince, there is some policies within Cluster API about versioning, or at least there was at one point I remember hearing. Is that a conflict? Because what I remember from, this is a long time ago, if I'm right, was each version of Cluster API was specific to a version that was actually released. And so you would update the component tree for Cluster API to update what versions were available to you to deploy. Am I misspeaking there? If you are talking, you are muted, and if you aren't there, that's fine. I can ask separately.
Sorry, you're talking to me.
Yeah, sorry about that. So
I was over there for 1 second.
No worries. I'll repeat my question. So I remember from a while back, and I don't know if this is still the same policy, but in CAPI at one point the policy was versions of the released Kubernetes versions that you could create with them were associated with versions of the actual control plane components, like the CAPI components. Or is that not the case? I might be completely wrong there, but I feel like that's what I remember hearing at one point.
So just to clarify, like the version of the of which components?
So if you had Kubernetes 119 and you were upgrading to 120, for example, you would typically have to update your CAPI controllers as well to support that.
That happened in the past because of breaking changes, but so Alpha 3 is actually the widest release so far, and we'll still keep supporting the new releases.
Okay.
It might happen that in the future we won't, like we're gonna say like, hey, you have to update the new version to get the new Kubernetes version, but like unless that's required, like I usually discourage that because yeah, we want to support like a wide range of case versions.
And it goes backwards as well. So if you're on 118 and you had like, if you have down to 1.6, is it basically like follows the version skew for it, or is it because the thing that I'm trying to figure out is it okay if from a CAPI perspective, or is this any breaking or weird implementation if we support, say for instance, in our controller we have versions for etcd that are 3.5.4, 3.5.5, 3.5 and up and down in both ways on the version skew? Or should we be versioning those separately and having releases for each one of them and not containing all of the backwards compatibility?
No, I would do the backward compatible way. That would be the way that we're doing that today. I should also clarify, like there is a minimum version for the management cluster, which is 119, I want to say, for Alpha 4, and it's 116 for Alpha 3. The minimum version is dictated by a few factors, but the workload cluster, it's like much wider. We do support like a wide version, but we don't support any downgrade. So that's, you can go back like from after you upgraded a cluster. There is something we want to support, though, is rollback, to make sure that like you could, roll back to the previous stable version, but we don't do that yet. So yeah, backward compatible sounds like the way to go, and making sure that you can only go up. It's actually like a good limitation to put in place when you're starting up.
Okay, cool. All right, so that answers that then. So we can maintain as many channels, as many versions as we want under the channels, but we can specify what is our stable version at the current time.
Okay,
yeah,
sounds good. Yeah. Okay, so I will keep the current implementation and we will merge it first, and later we will move forward. We will try to align with the implementation of the declarative pattern.
Yeah.
If that sounds good.
That sounds great.
Okay. So okay, let's talk about the second issue I have. So I discussed with you last week, and we agree with that the NCP controller are going to create the CA, the root CA for all the components, and each nested component component controller will be responsible to create the actually certification and certification based on root, right? But when I implement, because I forgot when I discussed with you, I forgot that when I like actually sign a certification, I also need the RSA key paired with the root CA. So I think, is that possible to store the RSA key inside the secret as well, or do you think that is sensitive?
I'm trying to think of.
If we store the key inside the secret as well, then anyone who can read a secret will have the right to generate a certificate by the name of the root CA. So I'm not sure if that is secure enough.
Let's see. Yeah, that sounds slightly concerning. I mean, I want to, Vince, if you have background on what kubeadm is doing there, yeah, how does that actually happen? Because if kubeadm is not generating the certificates up front, and it's passing it down to the actual machines to generate, then how would that actually how would that typically function?
So for control plane, you have to pass like all the CAs and the keys to make a control plane initialize or join. For nodes, it's just the CA cert of the cluster. Now, like for secrets, you said like if you have read secrets, like you could use that certificates to potentially do something malicious. Like, are we talking about the management cluster or the workload cluster?
It should be specific for the workload cluster, because it'd be a single per workload cluster.
Well, you could have access to both, I guess, if that makes sense. So like, for the workload cluster, like the secrets are like on disk. So if you have someone that already has SSH in one of your machines, the security hole is, I would say, somewhere else, right? For RBAC, if you have like the management cluster, like it should be a little bit more tied down. Like you wouldn't want to give out like access to the management cluster to everyone, probably want to give out access to the workload clusters to your users. So there is the concern that like the secrets are stored. You could use, I guess, an external CA, but that doesn't really solve the question. Like you could go around it and like not like make it so that like you use external CAs and things like that, but then you have to generate all those things that, and management of those certificates becomes a nightmare really quickly, especially in in CAPI where everything is immutable. You want to delete and recreate machines, and then you have to generate those certificates. So, what is it you're worried about? That's another question. Like which attack vector?
Chow, do you have thoughts
yeah,
there?
so yeah, like Vince said, if we assume that the management cluster cannot be accessed by an average user, then I think it can be secure if it can be secure enough if we just have this assumption, and then we can store both the CA and RSA key inside a secret, and the secret is just on the management cluster. So the workload cluster will not have the right to, the user of the workload cluster will not have the right to access this secret. So that can be okay, I guess, if we have this assumption.
Yeah, and you may also want to like lock down secret access to the queue system namespace on the workload cluster so that they don't get the other certs.
Okay. Okay. Yeah. Yeah. That answered my question. Yeah.
From that side of things, so that's really to generate. So we get around this in VC, or in what you did in VC Manager, by doing everything at the virtual cluster controller and generating all the certs for everything. Now, I think going back to our chats, I think we talked about doing, you and I on Slack were talking a little bit about maybe storing the actual client certs from the controller instead, which would get around that. So if we basically had the NCP generate all of the key pairs while it still had the CA and the RSA key, we wouldn't need to actually pass that down, correct?
You mean if, did you just say if the NCP controller generate all the root, include root and also the certificate, everything? Yeah, that will be good. That will be good. Then I think then you don't need to pass the CA or RSA key into the secret. You can just store the client certificate and key inside the secret. That will be enough for all these components to talk to each other, because etcd only need to talk to API server only need to talk to etcd, and the controller manager only need to talk to API server. Yeah, so we only need to have two sets of client certificate and a key pair, etcd and API server. Just two secrets should be enough.
Okay. Yeah, and then we need a way to be able to generate them for being able to auth to kubelets or VN agent, right? As well.
Kubelets VN agent. Yeah, correct. Yeah, right. If we wanted to have another like kubelet client certificate, if my memory is correct. And also, yeah, I think we still need to have the CA stored in a secret someplace, because when you start the API server, you still have to have the CA of the etcd. Then you can use it to check if
to set up the authority.
Correct. Yeah, right.
Okay, so what I ended up doing is this morning I went around and I went back and updated my NCP doc. So I hadn't had a chance to poke you and say if you can go give that a read. But in essence, what I ended up doing was writing it up as though we would do generation of the client certs as well, and do based on our chats. Sorry, everybody, you weren't all a part of this because we did this in DMs. But in essence, we were chatting about how we could potentially store the etcd client certs based on the same name prefixing that we use in CAPI. So let me actually just share my screen and I can show what I ended up writing up. I did a little bit of a TBD on some of these things because I don't know all of the certs that we're going to need to generate, and we can always mutate this later. Let me share my screen again. So in theory, if we go down to the cert, so basically what I ended up doing is calling out another piece, which is the key pairs for every single component. And so we'd have cluster name, dash component dash client cert, and those are going to be the key pairs, basically in essence generating very similar to what we're doing for the service account. And then we have so how that's all structured is all written out there. So we'd have etcd as a prefix, as a component name, proxy as a component name, kube controller or controller manager, sorry, as a component name, and then potentially kubelet, and then anything else we might add later, we can add into this list as known components as for other pieces that can get deployed as pods. How does that sound? That would make it so that you don't technically we don't need to store the RSA key in that same place, but I mean, we always need to be able to recall back to it to do refreshes on any of these certificates anyways. So we do have to store it at the end.
Yeah, so the NCP controller will be responsible for creating all this secret and store all this thing. Okay.
Yeah. That way you don't even have to. So you basically just get everything you need and just kubectl apply it, and then you're in essence a deployed component.
Yep.
Does that seem reasonable?
Yes, that seems reasonable to me. Yeah.
Cool. All right.
I think we missed the API server. Are we going to have a secret responsible corresponding to the API server?
Yeah. So right now I only have it as the proxy cert, but I guess I can make another one. Yeah, I'll add in another one that is the API server as well. So
okay.
I'll update that. I did a couple other updates to there to resolve everybody else's feedback on that doc if you want to give that another read through as well.
One thing though you might want to think about, Chris, is like I've seen like you don't have anything else apart from that API server. How are you going to handle like certificate rotation and things like that when you want to upgrade?
Yeah, so if we do it at the NCP level, how do we upgrade an individual component, or how do we renew the certs for an individual component?
Like maybe you want to use the pod name that you're creating as the suffix or a hash of that, because then you can use you can create new ones when you regenerate that pod. I mean, when you roll out a new version and things like that.
Okay. All right. Yeah, that's a good idea. Let me think about how we could do that. Since
Chris,
yeah.
Why we don't use a certification manager to do all these things?
Because we can't. Yeah, so we can't expect everybody's going to use cert manager for their deployment, and so we need to have a common path for people to be able to provide their own certs for how these control planes will get brought up.
Yeah, but certs is complicated, correct? You have a different things, so better to have a common place to do that, so people can replace it if they need it, instead of you put into each component and implement it.
Yeah. So the idea there is Cert Manager is an add-on that you can use, and by having a common named secrets, you could overwrite those by saying in your certificate resource with Cert Manager, you specify the name of the component you want it to generate a cert for, and it will generate the secret into that. It'll generate a secret and store it in that name that you specify in your certificate. And so you can override anything that's in this doc by using Cert Manager, but we need to have something built in that will at least manage it at a self-signed way. So that we can deploy this without Cert Manager as well.
But Cert Manager is required for copy, so
I thought it was only it's required in v4 but not v3, right? Or
no,
is
it's
it
required in all the versions?
Okay.
Because it's required for Cube Builder, and so.
Gotcha. So should we?
We actually install it for you too. Yeah.
Interesting. Okay.
So I think if the certificate manager can generate all these things, then, and also can do the rotation, like certificate rotation, I think it can be a good option, right? Because if we do not use certificate manager, then the NCP controller have to be responsible for the whole life cycle of their certification. We have to do rotation, update, all this stuff.
Okay. All right. So if we were to do that, if we were to basically make it so that it's a requirement on cert manager. Yeah, let me spin my wheels on that one a little bit. I'm trying to think if that would cause any issues. To require cert manager to do the generation for the certs for the control plane components, because I understand why it's there for, at least for the CAPI control plane, but I'm trying to figure out why it would be there for, if like kubeadm is typically generating the certs and managing the certs for the workload clusters.
So usually, like, we can't use cert manager because kubeadm runs on the machine, and it's like too early for that workload cluster to actually have those certs. But in this case, like, given that you might, well, I don't know how, like, you will have to figure out like attaching of nodes, but for the control plane, you could leverage cert manager and just create those CRs and get the secret and push it down.
Okay. Okay. All right. Yeah. Let me think through that then and see if I can update this doc for what that would be. I basically in my original writing of this wrote that you can use it. You can supply your own certs with this, but we're going to follow the same path that we have with the kubeadm control plane and Bootstrap provider. That it does some of that generation for you if those aren't supplied or if those aren't generated for already. But I guess that makes sense. All right. I'll spend some cycles and update that, or and think through how that would work.
Sure, I think certain manager definitely, if Chris, you think it is reasonable, we can definitely go there. But my current worry is I don't know how much time we are going to spend if we really bring that all in, or if we do POC stuff. But if we want to make our March milestone, is this okay? We just do some, simple, just leverage what VC manager, part of key management, very simple. There's no upgrade story. But again, our first release, and we can put the manager in the next release, I think, which is more reasonable. Because this is a blocker. I don't want to spend another 2 weeks to explore how to resolve this blocker.
No, that makes sense. I think the biggest thing that we need to solidify is what the names should be on those, so that we don't have to change the names on the secrets. And I think those at least are solid because those follow the same format that we have in CAPI. So if we can follow those patterns, use what we have in VC Manager to implement the in-tree, but then also be able to support overrides with Cert Manager, then we're okay. I think that makes sense. And then we can iterate on it. As long as we keep a common naming format, we don't need to worry too much.
Exactly. So because, upgrade, key upgrade is a long story. I mean, it won't happen very frequently and not near future, right? So it's not blocker to me. So the blocker is we have to make sure all these certs are available. Otherwise, other components cannot be used.
Can't come up. Yeah. Okay. Yeah, that makes sense. Yeah, so then I'll probably go through here and change a couple of the pieces in the doc about using the kubeadm stuff and point more towards the VC Manager code base, and then we can generate, or we can leverage those, use the new names, and then and move forward with that.
Yeah, sounds good.
Cool. All right. Does anybody else have anything that they want to bring up? We're at the end of our agenda for now. At some point, Faye, if you get a chance, it would be super awesome still to do a demo of what you're doing with the experimental stuff, but that's separate from this, of course, right now.
Yeah, can discuss, but not today, because I wish I can do the, I wish I can do the, kind of little tutorial this week. So
sure,
we get everything done, and and my demo would kind of go through that tutorial. So
cool. Okay.
So another thing is maybe we can take some time to discuss things. When he is here, we can discuss his PR about the example controller for the CRD.
Okay.
Yeah.
Yeah. So my So I think I agree with what Chris's comment generated. I think that controller can be as simple, as generic as possible. I was even start thinking it's just just has some document, but you put actual code in that. So I think it's okay. But I agree with most of what Chris was mentioning, say using the name like just full.
Okay, I can change the name to full. Yeah.
Yeah. My little bit concern is you put sample code like like all the patroller, DWS, UWS syncer. My worry is that are you going to have to make consistent every time we change those? So because this is not like interface code or framework code, which is kind of pretty stable. It's still kind of working piece. I'm not sure is this good enough to just put actual code there, or just use kind of documents to describe what you are going to do. I don't know which one is better, so that's why I want.
I think the code is just example that we can. It's not to enforce people to use it, but I put there just example that how I use this your framework to generate another syncer that if anyone want to do the separate the syncer, or they want to combine with your existing syncer, that you can combine a big syncer, including the not optional component, but also this CR, which he defined separately. So this is how it works. So when you change the infrastructure in the future, I think you evolve very quickly. But I still hope that people can still make sure this kind of some implementation, which some company like us we did, can be compromised. That people when change your infrastructure code not too dramatically that make this piece not workable. But this is not enforced. Just put there to make sure we have example and people can contribute on it and enhance it. The start point, because just writing, I already finished writing, so the code is there is shouldn't matter, correct, for your entire.
So here's I'm probably wrong, but just my initial thought. I haven't fully think through all the process. My little worry is if you put it the way like you did, you have a make file. So the assumption people is here, I need to make something, and the make file should just work.
I will put the make file separate there because this example. So if you look, the structure is totally like a separate syncer. We build start root from example is not from the virtual cluster. So I will put the make file there so that people can build it and to fill it. And if they have time, they can enhance it in case I make something wrong. But it's quite complicated. That's I make everything work now. So it dynamically can introduce CRDs. Then now the CR can be synced and can be patrolled. So this is maybe someone, yeah.
I wonder.
My point is you can do that way, but so we have two ways to do. So if we want to maintain that, so the problem is how to maintain that, right? If we want to maintain that, which means every time we do the change in the main syncer repository, I need to think about, oh, there is an example there. Should I change that file as well? So that's kind of, it's okay if we all agree we do that, that's fine. So on the other hand is Rose example directory is maintained separately. So somebody else like you probably need to think about every time we make some change in the main repo, that can be part of my example. Otherwise, if people really use that example, will get a mistake. Or if, for example, if I fix a bug, so if there is a bug in the main code, so who is going to point that bug to that example directory?
Yeah. So the way, if you look at the code currently in the example, except this API, the full the CRD CRD APIs, which is generated, this is separately. But if you look at the core of this code, it's just one of the syncer component, like underscore source CRD. Now is a underscore source score slash we call the project as a or full. So this is like one component, very slim, very slim. There everything is imported from your infrastructure. Nothing was actually there. So there are only actually 3 files, which can be put as a component under /resource.
Yeah, I think I need to double check. I thought you are doing some copy. If you just do importing,
No, yeah, everything imported. So this you can consider it is just slash resource, resource slash component. This everything is there, and nothing else from. So actually, I can even check into the resource slash directory as a new component, a new sync component like a CRD example. But we put example is that I don't want to interfere with your infrastructure. So everything is just imported from your main infra.
For example, you have a checker.go, right? You have resource project checker.go. You have all the patrollers implementation. You have
check.go, yeah. Yes, checker.go. So this is checker, controller, and DWS. This is 3 components that every component in your syncer need to have, correct? It's just like a...
My point is, so if we change something in those 3 functions, for example, we fix some bug, we do some refactoring, in the main repo, not this example repo, are we going to port those changes to this example?
Yeah, if you do the idea is that hopefully if people do this big change, also should consider this kind of a, if he agreed this example CR resource synchronization, he should also do one step to make sure that will also comply, because this is just as the exact same kind of a component as the normal syncer, which we use it. So I don't want you to make dramatic change in the infrastructure so the people very hard to use your infrastructure in the long run. So this is one way to make sure our infrastructure is generic enough so everyone can benefit from that. This is a good thing for the infrastructure. That
real quick question for you, Faye, are you suggesting potentially taking this instead of doing it as actual code and basically taking in essence these files and saying, if you wanted to implement something very similar, here's a markdown file in the docs directory that says these are the potential things that you would implement and what a DWS should look like almost pseudocode, like it should look like this. You should have a patroller that looks like this. You should have a UWS if you wanted it to look like this, not actual implementation, so that we don't have to maintain implementations. And then you can just point and say, oh, you could import this command file and it's going to automatically load everything for you. I see.
Yeah, my original thought is just something like pseudocode, kind of pseudo blocks, just explain what you should do. I didn't expect a comparable, something that can be compiled to the binary. I thought that would be so tightly decoupled with the real synchro implementation. And every time you
but I think a good thing for you, the synchro infrastructure, that the people do use CRDs and they do have dependence on your infrastructures. So like recent, some of the changes are so dramatic, and of course it's good way is not to break a lot of things, but it do have some complication on this CRD, our component. So in this thought, I put this component in, so at least when you change the infrastructure, you need to have some reference that, oh, people use this way, so I have to change, make sure it's still compliant. It's not dramatically change, only think of this 10 the standard component in your syncer. I think this is good for the long run for the syncer infrastructures.
Yeah, I totally agree with you, but but the problem is, even the syncer has been there for a year, but I would say it's still in very early stage. So we don't even have a formal formal release yet. So which means, I mean, at least for currently any code change or any code refactoring, we were thinking we shouldn't worry too much about breaking kind of others, because we are not even release even a beta version. So that's a reason at least at this moment I don't want to put very strict enforcement on how we change the infra code, because it's not a good implementation anyway. We need to change it, right? So if we release something, for example, we formally release any release we have formally released, then we need to think about, any changes we need to be very cautious about where that break others. So that's a reason. But I agree with you. Once we release it, it has to be stable. We need to think about all the how to break, make everything is backward compatible.
Yeah, if you can, same thing for your experimental kind of directory, which you put this new things, which also do the thing. But I think you also depend quite some on the infrastructure code there.
I have to. So
yeah, so same thing. So this give you some vision that because this infrastructure is so nice that can serve a lot of purpose. I have some new ideas to make it to even grow on different angles. But with all this in the either in the example is experimental, is tightly, not very tightly combined with your existing code, but at least loosely coupled with your infrastructure code, which gives us at least some reference, at least for the people to work this way, unless you don't really agree on the implementation I did with the CR thinkers, then we can discuss otherwise. If you agree that, I think this is good example that we use this way.
Yeah, I think sometimes as a project getting bigger and bigger, I think people will face this kind of thing, right? If we kind of, for example, we have so because the example CRD, you can treat it as another kind of experimental features, which is can stand alone, which is standalone things based on the base thinker infrastructure, but you do something else. But if we agree that, for example, for the scheduler that I was doing, so I never ask, anybody you can change thinker whenever you want. You don't need to think about the experiment. I'm going to think experiment to matching the latest infrastructure. So at least, so I'm not asking everybody to change something to make sure the experimental can work. So on the other hand, that if you think, okay, you don't want to put extra constraint or burden on anybody to change the thinker code, so you are going to be responsible to think any changes on the thinker to the experimental CRD. I'm totally fine with it. So
yeah, I agree. So at least I have a point to start to discuss it, because if I lose this code after several months, people change this infrastructure, I have any base to start with, because it's very complicated things. Now, if the code is there, at least I can point out this some certain line that with your new change is make difference. So this way, at least there is a reference point that I can start to talk and make sure the guy who changed the infrastructure code can rethink, is this the best way or not? If he thinks the best way, then I will do the change on my side, the example code, make sure it's compliant. But at least the code there, we can have a start point to discuss why your infrastructure change is good or bad. So at least I have some reference. If I just put a document there, no code, it's really hard to put everything there. So we cannot even start to talk.
I kind of disagree with that in the sense that if you want to discuss whether some code was good or not, it shouldn't be happening a few weeks later. It should be happening right away in the PR. So that
in the PR, so I can point into the code. So for example, you did a big PR to change that. So then I can point to this in a review. I can tell him that, okay, if we want to compromise something like in the CR thinker, like in example, if you do a little bit change this way, that would be nicer. Or at the end, he's not agree on that, then I will go back to change my code to comply with this new change. So there, at least we have one round of the discussion happening. It's so that people can double think if his new PR is good enough or has some enhancement. So this way we have to can start a discussion. Otherwise, it's hard, because when you do a PR, I have my code, and I also forgot this code. So maybe the change is very hard to in the CR area that cannot be seen, cannot be reviewed.
From a maintenance perspective, I think is really what Fei is getting at. Trying to maintain this going forward and making sure that we're keeping everything in sync. And in essence, I mean, if you look at a big project like Kubernetes or anything like that, you don't really see example sample controllers, for example, being in tree in here. It does feel like this could be written as a relatively simple doc that says, if you want to go through like tutorial, like we have for the tenant DNS, if you want to go through this, these are the 5 steps that you have to do, or 10 steps that you have to do to go do this. And here we can basically take everything that you did, copy it into Markdown, and then we don't break potentially build time. We don't break any build life cycles as we get this all this code moved over into CapN. And we have to actually run it through CI processes, since we don't have any of that in the multi-tenancy repo. So I think it probably does make more sense from a maintenance perspective to make this a document instead of being example code. Now, Wei, you and I can try and talk through what it would be like to do this in another repo. I doubt we'd get something from the SIG side of things, but potentially we can talk with our OSPO and figure out if there's a way that we could publish this separately. Otherwise, we might maintain this internally, just as here's sample code for our folks using it, and then otherwise point to a document that we wrote instead. So basically take the 3 files that you have, in essence, convert those into parts of a markdown file that says, this is a patroller and a patroller does this. And this is how you would write one that looks very similar for a CR, and all of like a walkthrough like you'd get out of the book.kubebuilder.io, for example, to make it a little bit easier to follow along. Because right now, yes, the sample code makes sense and it's easy to go look at and walk through. But I think being able to explain it a little bit deeper is going to be much better, much more beneficial to someone trying to pick these things up and build these art themselves, versus having example code, physical example code that's compilable. Because they can always go and look at what the patrollers look like in any of the resources and any of the DWS or UWS in any of the other existing resources as more reference for compiled examples. And those are always going to be more up to date than an example directory that's just in the repo. Does that seem to echo what you're looking for?
True, yeah. So, or you want me to put into the experimental that I maintain it for you, or?
No, I don't want to put it in the experimental. I want to put this in because it's not really an experimental feature. I think we should put this in a markdown file in the docs directory. So go and write a very short tutorial. If you want to make a custom sinker, what do you do? And walk through the process that you've done multiple times to build these sinkers before, and Faye's done, and Chao's done, and Jerry's done, and everybody's built these things, but now we should probably make it more concrete that says, okay, these are what the different components of a sinker are. This is what each of those different style sinkers are, and how you would write them yourself if you wanted to do one for your custom CR. And then you and I can talk and try and figure out if there's a way that we can house example code somewhere that's not in tree, so not in this actual repo at all. So that
if you both agree on that, and then I move it, I close this PR. So yeah.
You don't have to close this PR. I mean, you can keep the PR open. We can move this into a docs file instead, and make those Go files either referenced into or loaded into. No, they'd have to be copied over into a markdown file as like the tutorial for how to do it. That makes sense.
Yeah. I think that's exactly what I'm saying. So you can even put that sample code in the markdown file. That's okay, but just don't make something that's comparable. The compilable. If you make comparable, so as I think Chris got a good point. So you need to make sure it doesn't break CI. So it can be annoying if the project getting bigger and bigger. So every time there are some compile error happens in the example directory, so yeah, that's my point. I think especially from any people want to write sinker, I think they cannot be a dump developer. They have to have some understanding about everything that has been working. So just show them, what are example code, and if you just tell them, please copy these 3 files and do a SED replace part to CRD, probably just will work. Yeah, something like.
Yeah, because then you could really talk about the intricacies that you had to deal with there. Like, keep the changes that you had to do, because you did have to make changes to the like core infrastructure of the sinker. I noticed that, like, you had to make sure you had to export the meta fields that weren't already exported. Those were typically unexported functions in there. So like, keep all of the code changes that you had to do this to make this possible, and then write it.
There's only one place that the meta file I need to change, but it's optional. I can copy it. This is about
no. I'm saying
code, yeah.
Keep those in this PR, because I think those are good. I mean, I assume that Faye would agree. Like, if we need to export functions so that we can build these custom these custom sinkers and not have to copy a bunch of functions, let's make sure and push those upstream or push those into the core sinker. Keep those changes. It's just, instead of having those 3 files that are an implementation of a foo sinker, let's just put those in a in a markdown file and says, hey, we're going to take this sample controller foo CR, and we're going to show how you would write a DWS and a UWS and a patroller for this to do X, or I mean, to sync resources for your custom components.
Yeah,
and then
it's kind of just explain a diff. Kind of you copy something and you make a diff. Just explain that diff, and it's more valuable to me because now we can look about we can think about potential optimization of the code structure to make sure that the diff as small as possible. So that's all our purpose, right?
Yeah, and just to show, sorry, I'm going to share my screen for 2 seconds as well, just to kind of show what I think we mean here. The perfect example of this is the tenant DNS stuff. So to do our forked core DNS, we didn't fork core DNS's code base and put it in the repo and make it something that's compilable from here. It explains the problem state, what you're trying to do, the solution, and then exactly as Faye's saying, okay, what would the diff be to actually make this happen? So in this instance, it's a little bit easier because you can just copy this and like execute the patch for this. For us, it's probably going to be the example code that you already wrote in each one of those files that goes in here. And then it will go through, okay, once you've done this, you need to write a command file that imports these things and imports your new syncer. And then from there, you're good. So in essence, taking those 3 or 4 files and just putting them into Markdown.
Okay, I can do that. Yeah.
Cool. All right. We're getting close to the end of the hour. Is there anything else we wanted to bring up before we drop off? Otherwise, we can see everybody next week. And yeah. Fantastic, everybody. All right. See y'all next week. Have a great week.
See ya. Bye-bye.